What's up, interweb? Okay, this is the second part of the final exam review. Hopefully, we can get finished with it before the program here doesn't let me go anymore. Now, evaluate by rationalizing the denominators. Sounds like a disease, doesn't it? Now, I've written it like this: 4 divided by the square root of 2, but it looks like this also. So what we want to do is we want to get rid of the irrational number in the denominator. So what we're going to do is we're going to multiply by square root of 2 over square root of 2. Now, any number divided by itself is 1. So we haven't changed the value of this in it, we just changed the look. This is 4 times the square root of 2 over square root of 2 times the square root of 2 is the square root of 4, which is 4 square root of 2 over square root of 4 is 2. And we can reduce this fraction here. So this is 2 times the square root of 2. Number 19. Again, we're going to evaluate by rationalizing the denominator. It'll be 3 divided by 6 minus square root of 2 closed. Now this is the same thing as 3 over 6 minus square root of 2. Okay, now we want to get rid of this. So what we do is we multiply by the conjugate. Now what will happen when we multiply by the conjugate is the middle term, the linear term, will be eliminated. So we're going to multiply by 6 plus square root 2. 6 plus square root 2. And this is going to be, remember, this is in parentheses here. So this is going to be 18 plus 3 times the square root of 2. We're distributing the 3 over everything inside here. Over. Now remember, when you multiply them by the conjugate, all you really have to do is multiply the first numbers and the second numbers. So what do we have? 36 minus, okay, square root 2 times square root 2 is the square root of 4, and the square root of 4 is 2. So this equals 18 plus 3 square root 2 over, what is that, 34? And let's see, we remember, if you want to reduce the fraction, it has to be for both of these terms, not just one. So those won't go, so that's all there is there. Number 20, combine radical expression. Hold on. Okay, combine the radical expression in lowest terms. Now, excuse me, square root of 14 and square root of 14, these are like terms. This one is not. So this is going to equal. So we add these two together, we get 16 square root of 14 minus 15 square root 7. Nothing we can do there. Number 21. Okay, again, we want to combine radical expressions in the lowest terms. Now, what we need to do is factor the 75 into two numbers where one of the factors, is a perfect square. (25 times 3 is 75, and 25 is a perfect square, so we can do that. 6, and this is 16 times 3. Okay, so this is 20. The square root of 25 is 5. 5 times 3, square root 3, plus square root of 16 is 4. 4 times, where are we, 6? Square root 3. So this is going to equal 15 square root 3 plus 24 square root 3. Now these are like terms. So this is going to equal, what is that, 39? Okay, we just add these two together, because these are like terms, 39 square root 3. Okay, number 22 is evaluating the lowest terms. Now remember, when we have a negative on the inside of the radical, it just comes out as 1. What this is square root of -1 is I. So what we're doing here is, let me show you like this, right? The square root of -1 is I. The square root of 25 is 5. And that's all there is to that. Okay, same problem, or same type of problem. We have the square root of -48. Now, what happens here is, because there's a negative on the inside, we just bring out an I. And what are the factors of 48 where one of them is a perfect square? 16 times 3. Okay, now the square root of 16 is 4, so we bring that out of the radical. So 4I square root 3. Okay. Okay, this one is, what are the possible rational zeros of the polynomial? I don't want you to find out which ones are. We'll leave that for your other math class. Now remember, the rational zeros are P over Q. Okay, this one's P. This one is mm, mhm. That one's Q. So P is 6 over 3. Now what we want to do is we want to factor the 6. And that is, what are the factors of 6? 1, 2, 3, and 6. Right? Right. And what are the factors of 3? 3 and 1. So now what we do is we take these. Okay, let's just start with the 3. So it's going to be 1 over 3, 2 over 3, 3 over 3, which of course is 1, and 6 over 3. Now we did these over the 3. Now we do the same thing over the 1. Excuse me. 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Now we reduce the fractions. 1/3. Now remember, this is 1 and this is 1. So we don't have to write it 2 times. 2/3, 1. Okay, and 6 over 3 is 2. 1 over 1 is 1, we already have that. 2 over 1 is 2, we already have that. 3 over 1 is 3, and 6 over 1 is 6. Okay? Right? Right. I think that's right. 25. Okay. Number 25 is, what is the domain and range of this graph? Okay, so our domain, it goes from the smallest number. Domain, again, is side to side. It's the x's. So how far to the left does this go? -infinity. And then how far up does it go, or to the right does it go? 4. And again, there's a circle there, so it does not include 4. Now, it continues on, so it's the union of 4 to positive infinity. Right? Right. Now, the range is up and down, and it's kind of the same thing. How far down does it go? negative infinity. We use a parenthesis because infinity does not end. And how far up does it go? It goes to here, which is 0. Union 0, 0, stupid, and positive infinity. Right? Right. Okay, now number 26 is use synthetic division to evaluate. Is the divisor, in other words, this number, a factor of the numerator? This will be the numerator here. So the first thing we do is we set x minus 3 equal to 0. So x is going to be 3. So we do this. 3. And we take the coefficients of all these and be sure that we have all of the factors. It's cubed, squared, to the first power, and a constant. So we're good. Okay, the coefficient here is 1, so we put that here. The coefficient here is -2, this one -5, and we put the constant 6. And we bring down the 1, and we do 3 times 1 equals 3. 3 times 1 is 3. Now we add these together. 3 minus 2 is 1. Same thing. 3 times 1 is 3. 3 minus 5 is a -2. 3 times -2 is -6. So we have a remainder of 0. If there's no remainder, and there is not one here, then yes. So therefore, x minus 3 is a factor. Right? Right. Okay, number 27 is calculate the vertical and horizontal asymptotes. And here is a description of how to calculate those. The vertical asymptote, we set the denominator equal to 0, and that says solve, and solve. So we set the denominator, x minus 4 equals 0. So we add 4 to each side. So our x is 4. So our vertical asymptote is 4. Our horizontal asymptote is we look for, is the coefficient of x, is it great? It's greater than the denominator. That's a numerator greater than the denominator. Numerator greater than the denominator. So there is no horizontal asymptote. Okay? Okay. 28. Okay, number 28 is find the inverse function. So we know that f of x, you're given this, f of x equals 3x minus 4. Now f of x is the same thing as y. So now what we do is we exchange the x's and the y's. So y becomes x equals 3 times y, okay, we just inverse those, minus 4. Now we solve for y. Okay, so what we want to do now, we add 4 to each side, and we get x plus 4, these are not like terms, equals 3y. Now we divide everything by 3, divide by 3, divide by 3. So y equals x plus 4 over 3. Therefore, f of -1 of x equals, stupid boy, x plus 4 over 3, or x over 3 plus 4 over 3. Okay, this one, write the log in exponential form and solve for x. Now remember, this is the exponent over here. That's what the logs are really all about, is finding the exponent. Okay? So it goes this way. 5 to the third power is log base 5 to the third power equals x. Okay, and 5 cubed is, what was it, 125, I think. 5 times 5 times 5. Mm-hmm. And that's all there is to that. Very simple. Last one. Solve the log for x. Okay, now again, remember, this over here is the exponent. And we go like this. Log base 5 of 7 is x. So it's 5 to the x power equals 7. Right? And remember, these are the base numbers here. So what do we do here? We use the change of base formula. Hang on, it's telling me I don't have any time left. Okay, so we use the log of 7 divided by the log of 5. Right? And now what we do is we put this in your handy dandy calculator. I'm going to use this one because it's easier. First you turn it on and you get log of 7 divided by log of 5. Double check to make sure you entered it right. And you get roughly 1.21. Approximately equal to 1.21. Okay, now how could we double check to make sure we're right? Put it back into this. 5 raised to the 1.21, does that approximately equal 7? Let's see. 5 raised to 1.21, 1.21 is 7.0, dangerously close to 7. Okay? Okay, so this is our answer right here. We just double checked it doing that. Wasn't that fun? Okay. I'll take care. Bye-bye. Bye, Bonds.